to tell you about APERTVS, which for now is the largest scale open model, yet pre-trained on European infrastructure. That's also in conformity with European AI regulations. And also, it's maybe a bit of a brag, but what I think might be the largest academic AI workload ever run. So I'm happy to tell you about it here today. So to start off, I'll take a moment to reiterate kind of something that you all know at this point about the state of the world that we live in. AI technologies have blown up in the last few years, and we're really seeing an acceleration of these capabilities that are manifested by AI systems. And this is leading to absolutely transformational changes in many sectors of society, in large part the economy, where today over 36% of occupations are now being classified as using AI in a substantial way. And I can also say from my own backyard in education and training, the same as many of you, I think we'd all agree that it's easier to count the students that don't use Gen AI for schoolwork than the ones that do at this point. So clearly a transformational, huge impact that's almost alarming to quantify. At the same time, there's some key challenges in how AI is being deployed today. And really, many of these dynamics are kind of reminiscent of previous transformational eras where innovation really outpaced understanding of technology, such as electricity being discovered and invented in the late 1800s, and the impact that had on society at this time. The first is that the development of the technology is inherently quite undemocratic. Most of the models of today that are at the frontier are developed by a few private companies, typically behind closed doors. And that, in essence, by design, almost makes some of these models a bit untrustworthy. Where these systems are deployed, we know they have flaws, but there's really no transparency around what these shortcomings are, and it seems like we have to discover them along the way after they're released. And of course, there's something that we all know, which is that, in general, society has shown itself to be a bit unprepared for the rate at which this AI deployment has happened over the last few years. So what would we actually want to change about how this AI is deployed? Well, the first thing I would say is that we want to have systematic investigations, that we can continue to study the capabilities of these models, and to have the transparency that's needed to run real scientific experimentation, which is the subject of today's workshop. Importantly, we need this to be at relevant scale. I'm sure many of you have noticed in interacting with these systems, talking to an 8 billion parameter model is very different from talking to a 70 billion parameter model, and is very different from talking to a 700 billion parameter model. If we're not actually doing these scientific explorations at the scale where they can actually be translated to knowledge about the topic, we're leaving something on the table. That naturally requires transparent releases, where we can actually study these systems along the full pipeline of which they're developed, which requires them to be legally compliant with local regulations so that those transparent artifacts don't unleash, a wave of legislation. And finally, we want these artifacts that we study to be a reflection of the world that we live in, to essentially be democratized AI for all, so that we're studying AI in the context that affect the most people. So, what we asked ourselves a few years back is how we should try to accomplish this for next generation LLMs. And that was really the catalyst behind the APERTVS project that was developed at EPFL, and ETH Zurich, and at the Swiss Supercomputing Center. So I'll start off by giving kind of a brief overview of what APERTVS is. It's essentially a large language model at kind of the typical scales that we often see for language models today, one with 8 billion parameters and one with 70 billion parameters. These models have been trained on 15 trillion tokens of text, so a massive data set of web text that's been cleaned in various ways, and it was trained using up to 4,096 GPUs on the Alps supercomputer in Switzerland. There's full transparency around APERTVS, so you can really use these artifacts as open models to research, develop future AI systems, whatever you want. Everything that was involved in the creation of APERTVS is available for everyone. The reason we're not afraid to do this is that we practice responsible data practices, so we're not really afraid of getting sued, and it also satisfies most of the base model provisions of the EU AI Act. And finally, our last key point that we wanted as we developed this is that we wanted it to be globally representative of most places of the world. It was kind of surprising to us that most LLMs that are created, and pretty much all of the ones that are fully open, are completely Western-centric and principally English-focused. That was kind of crazy to me because we surveyed the landscape and found this, but there's really no fully open scientific artifact for LLM development that reflects kind of the most basic pluralism of the world, which is that we all come from different places. So a real goal of APERTVS was to change that. And as we can see in this graph on the right, we ended up in this development with a fairly strong benchmark performance within the class of fully open models. So diving, into a bit more detail, as I mentioned, there's really unparalleled openness for science at scale with the APERTVS systems. We wrote a 120-page report on the process by which we did it. We released all the source code, all the scripts for deploying it easily. It takes 2 lines of code to now deploy APERTVS on a laptop. We released our training data pipeline, so you can reconstruct all of the data that we actually used in the order in which we actually trained on it, all our evaluation harnesses so that you're actually able to see what types of design decisions we make to get the numbers that we end up reporting. And of course, we release model checkpoints throughout the entire course of pre-training, so you can grab an artifact at any point in that process and do whatever kind of scientific study you want on it. As I mentioned, one of the reasons why we can pretty much show you everything that went into the system is that we have absolutely no shame in showing you what we trained on. We only use public and version data, so no kind of private data sets based off textbooks to boost performance. We respected the AI opt-out preferences of authors, not just at the time of the crawl, but retroactively going back in time, so that as the time we started training, no one that had opted out of AI training had their data in our data set. We used special objectives in order to memorize memorization of data, so it's less likely that the model would spit out, exact transcripts from books and other copyrighted content. And we really made a huge effort in data quality across multiple languages, removing personally identifiable information, toxic and harmful content, and other forms of low-quality data such as spam and non-human text. As I mentioned, we tried to make APERTVS as globally representative as possible. While most other open models essentially throw out anything that's not English, and most other models throw out anything that's not in the top 20 or 30 languages, we trained on over 1,000 languages that we found in our training data, and really the training data reflects the natural distribution of languages that you can find on the web. Only 60% of the training data is in English, and then there's 40% non-English web data, including many of these low-resource languages that are typically not modeled by current systems. One of the happiest things that happened to me after we released is that we got this email from an educational program in Nigeria that essentially wanted to test out how well our model did for Igbo and Yoruba so that it could be used to run a workshop in Nigeria, which I think is a fantastic application of what these models, how these models can perhaps improve the lives of people all over the world. So what do you actually need to make a project like this happen? Naturally it's great to have a plan for improving LLMs, making them transparent, data compliant, and globally representative, but you need to be able to do it. It's a far cry from being able to execute it. Well, the first thing that you need is a supercomputer, unfortunately, which are getting easier to find these days, but still pretty rare. So Jus van de Wandelen, the deputy director of the Swiss Supercomputing Center, tells me that the full cost of training APERTVS was close to 10 to the 25 flops, which is around 4,096 GPUs running for 3 months for our largest model. I think our actual all-in compute time was closer to 2 months for pre-training, and then an added month for all of the cumulative experiments that had to be run along the way. But regardless, you need a ton of compute to make that happen. And we were lucky enough to have ALPS, which was inaugurated in 2024 with 11,000 GH200s, and was built by around 100 plus people at CSCS. What's important here is that it's not just enough to have a supercomputer. These are often AI-capable supercomputers, but not AI-ready when they first come online. And it actually takes substantial development along this type of workload to make them operable. If you see this graph on the bottom right, the top part is essentially what our throughput was for training when in April 2025, when we started trying to run the large workload of 70 billion parameters, and a month later when we actually kind of figured out how to stabilize the throughput that we could get and make and actually do the type of training that we wanted. Despite the engineering challenges, though, it's actually not all engineering. There's a massive amount of science that goes into this endeavor as well. We spent 12 months on this, got around 20 research papers out of it, along diverse thrusts that are necessary for LLM development. There were 100 students involved, so it's a massive opportunity for training and education as well. And really just to show that these large-scale AI projects don't actually need to sacrifice research and education in in order to get it done. It's not all just engineering. And there's really even more opportunities beyond the project itself. You know, the education and training component doesn't really stop at the contours of the project. It can be used to catalyze and excite a broader innovation ecosystems. So one of the things that we did is we timed the release of APERTVS around a month-long national hackathon that we actually co-organized in Switzerland as well. So that happened at the same time as the release of the model. We released on September 5th. The hackathon started on September 7th, and it brought together 154 partners in 15 hackathons and 240 events around Switzerland. Over 4,000 people participated, and it ended up building quite a few prototypes for APERTVS. Some of my favorite examples that are a bit, meta-oriented are the Swiss Hiker app and the Law Agent AI that helps you start a startup yourself. Now, not everything's going to turn into a startup, but it's a great starting point to then, try to push some of these projects that seem promising towards a commercialization angle. Finally, I'll end by mentioning our other key enabler, which hits on these topics of networks of researchers such as Ellis. Bringing together 100 people for this type of project is a lot easier if they're already talking to each other and wanting to participate in these projects. So what we had done in 2023, long after Ellis, is that we formed the Swiss AI Initiative, which now has around 750 researchers and developers in Switzerland. And it really enables, having these people and giving them the opportunity to use the supercomputer really enables projects to actually be formed that are much larger scale than what they actually tried to capture. We can really leverage these supercomputing resources. So in phase 1, we actually gave 10 projects 10 million GPU hours each, and now in phase 2, we've given 20 projects 16 million GPU hours each, on a wide range of topics that you might think is relevant, such as 3D vision foundation models for radiology, foundation models for climate and weather, surgical digital twins, and of course, one that's close to my heart, APERTVS 2.0. So, key takeaways from the APERTVS project: it's a huge open model that has a leading performance amongst comparable fully open models, so really a great artifact for science and responsible innovation. It's multilingual, so it can handle a lot of contexts that aren't normally captured by other models, and really it's not just engineering. This scale at which we do this research really drives new scientific challenges. I guess to motivate everyone else to kind of tackle science at this scale in the near future, if you want to do the same thing where you are, the first thing you should do is get a supercomputer. Not necessarily an easy task, but critical. The second thing I would say is, pick your special sauce. Don't, try to copy what others have done before. We really focused on this idea of data compliance and large-scale multilinguality. Train students as a core priority, because then even if the project fails, the next one has a higher chance of success if these people have been trained. And of course, consider the larger R&D ecosystem in which you fit. For us, having the Swiss AI Weeks was a massive potential for getting this innovation out. So thanks so much to the team that actually built APERTVS. I just stand up here and evangelize, and thank you as well for being here. If you'd like to work with us, please feel free to reach out. We're obviously welcoming of international partners for phase 3 of the project.